to the 13th of October as part of World Hydrogen Week. So welcome, Monica. Thanks for joining me.
Thank you. Thank you for the invitation.
So you're going to be talking in I guess, quite a contentious area. Certainly, there's lots of areas for debate, but the one around hydrogen derivatives, and is there a specific, winning derivative, and what is the purpose of derivatives, and the debate is around what's the most effective way to transport hydrogen molecules, which you're going to be taking part in. So I guess it's a good place to start. You obviously have a background in catalysis and have studied all of the various forms, I guess, in some depth. So maybe we sort of start in that area around all these derivatives. We've seen, initially a lot of interest around ammonia, and then we've seen a lot of interest around methanol, specifically, I guess, coming out of the shipping industry. We've also heard people obviously talking about LOHC and its suitability, and finally, I guess, DME as well as has been mentioned a number of times. So what are your thoughts around that landscape, and why initially are we having to look at derivatives?
Yeah, I think so. First of all, I think the climate change, that's the global problem. It's not only the problem of Europe or Germany. And I think in this regard, we need to really work together. And what is, for example, the fact at the moment for Europe as a region, that we won't be able to produce enough energy for our economy, for our industry. And the fact is, we would need to import more than 50% of energy from other countries, from other continents. And here comes maybe the largest challenge at the moment, how to import, so how to efficiently import this hydrogen to Europe. And in this case, different derivatives comes, in the fact which would be the most efficient, and there are a lot of discussions. And from my perspective, I would say not only one derivative, one molecule will lose or this problem, but I think there would be the combination of a lot of them. And I think the solution would be really would depends on the final consumer, on the, for example, transportation distance. So are we talking about the overseas transportation, or are we talking about the maybe 100 kilometers transportation distance? For example, the hydrogen purity would be very important for the end user, and so on. So I think there are many facts, and I think we cannot say only this derivative will be used in the future, but the combination of different ones. So I think there are many of them. For example, you mentioned ammonia, methanol, DME, LOHC. So we have different technical solutions for them. Of course, I would say many of them have still some technical problems, which needs to be in the next, not years, but perhaps months, loosed. For example, when we are talking about the overseas transportations by ship, would be perhaps the most efficient at the moment to transport hydrogen in form of ammonia. Of course, there is still some open question for ammonia cracking, to build the infrastructure. Maybe some regulations is still missing. For example, the social acceptance is very important here, so that the people are familiar with this technology, that there is understanding. And of course, maybe LOHC is as well a very good option, maybe for the short distance transportations. We have then as well methanol, DME, where we need to consider then the CO2 capture.
Yeah.
So all these technologies have advantages and disadvantages, and I think the combination and the certain specific case will give us then the final answer.
Yeah. And I mean, in terms of I guess, you mentioned, I guess, distance as factors. So the purity, distance, I guess, toxicity, is an issue. Energy density, are there any? I mean, they have different. They're able to carry different amounts of hydrogen, obviously, for different. Is there one which is more efficient in terms of actually just carrying hydrogen, absorbing hydrogen?
For example, when we are comparing ammonia with liquid hydrogen,
Mm.
let's say we are shipping the hydrogen. In this case, has, for example, ammonia higher energy density. So just to compare, when we have the same volume, we need 3 ships for ammonia, and the same quantity will be, for example, with the 4 ships of then the liquid hydrogen.
Right.
So, the ammonia would be in this case more efficient. Of course,
and you don't obviously have to cool it for the liquid
exactly,
hydrogen. Yeah.
exactly. The liquid hydrogen we need to cool to minus 253 degrees,
Yeah.
which is extra energy. And for example, to transport hydrogen in form of liquid ammonia, we need to cool down to only minus 33 degrees. So there is big difference as well in terms of the already existing infrastructure. Ammonia is the chemical which we are using already 100 years. So regarding the safety, of course, there are some still open questions, but this chemical it's been used as a fertilizer. So we have the safety regulations, we have as well the infrastructure. Maybe the infrastructure on the other side, when we are talking about ammonia cracking, is still missing.
Yeah.
But this is still manageable. So yeah, and on the other side, for example, the ships for the liquid hydrogen are still in development. So they're still missing parts. I think the Japan built the first ship for the liquid hydrogen. You need some extra materials for this because of cooling down to minus 253 degrees is still a little bit challenging.
Yeah. And in terms of I guess methanol, I mean, you mentioned the need for carbon atoms and obviously you combine either carbon, capture some carbon, add it to essentially hydrogen to create methanol. That is obviously, we've seen a number of ships being ordered that are dual fuel. So obviously Maersk famously ordered a sort of 13 or 14, and now I think I've seen 4 or 5 other orders, so upwards north of sort of 30 odd maritime ships that have that capability. And speaking to the maritime community, I know there's some people that are concerned about ships powered by ammonia and specifically, engine rooms and issues with fuel leaks, etc. What are some of your thoughts there? Is there are practical ways to get around ammonia powered ships? Because obviously, if you're going to be transporting ammonia, I guess it makes sense for them to use the power source on board.
I think it's definitely manageable. The ammonia could be as well used as a dual fuel. For example, ammonia plus hydrogen. It would be even more efficient, for example, for the larger engines, for the ships. So I think the technical problems, of course, for any NOx emissions, we need to take care as well in this case. This is definitely not to be forgotten. But it's definitely manageable. So yeah.
And in terms of DME, which hasn't had that much press or interest, is there any? I mean, again, there's the challenge around the carbon molecule, but it is does it have a high purity, or what were some of the pluses around DME? And actually, what does DME actually stand for? Because I've forgotten personally.
It stands for dimethyl ether. Yeah. So it's synthesized from methanol, and it has higher energy density compared to methanol. So this is the advantage. And of course, regarding then the transforming DME to hydrogen is the question about the CO2. So, but this problem we have as well in case of methanol. Yeah, so the advantage would be the higher energy density. Actually, we have all existing infrastructure. This shouldn't be a problem. Yeah.
Yeah. And in terms of, I guess the uncracking or the use, I mean, obviously ammonia has a big market, and is obviously the first thing that needs to be cleaned up is to create, you know, a green ammonia market off from the existing ammonia market. And then equally, you know, there is a market, I guess, for methanol that exists today. Is there opportunities to use these fuels and not have to crack them out? So obviously,
Exactly.
people have mentioned, you know, co-firing ammonia in coal-fired power plants. Are there any other sort of new applications that could potentially be used? Obviously, there is also ammonia fuel cells. Likewise, are there other opportunities for DME and or methanol to be used in applications without having to crack hydrogen out? I mean, obviously, we've come.
Definitely as a fuel. But I think this is not something new. Methanol is beside the fuel as well used as a platform chemical in the chemical industry. So from methanol we can synthesize 1,000 different other molecules or chemicals. Yeah, definitely there is not always the case to crack either ammonia or methanol or DME.
Yeah. Okay. They
Definitely.
can all be used in
especially if when we are talking about these molecules as green molecules.
Yeah.
I think they have the additional value on top of this, especially when we are talking about ammonia, the green fertilizers.
Yeah.
I mean, ammonia is until now mainly used as a fertilizer. And that would be this additional value when we are using the green hydrogen to synthesize these molecules.
Yeah. Understood. Well, it's going to be fascinating. There's lots of debate. It's going to be interesting to see how the industry develops and which sort of applications begin to get taken up for which molecules, or the other way around, which molecules get taken up by which applications. But we look forward to your contribution at the World Hydrogen Week and the Derivatives Summit, which I think is sold out now. So lots of people coming. There's going to be lots of interesting questions, and we look forward to meeting you in person and listening to the debate. So many thanks, Monika.
Thank you, Nadim.
Many thanks. Take care.
You too. Bye bye.
Cheers. Bye bye.